Imagine that the reality you perceive is merely the outer shell of an endless gravitational collapse. The theory of reverse singularity proposes that the Big Bang was not an isolated beginning, but the violent ejection of matter from a white hole. If general relativity in 1915 allowed for the existence of regions where light remains trapped, the mathematics of 1935 revealed its geometric opposite. We are inhabiting the interior of an event that, to an external observer, appears as a devouring black abyss. This inversion of perspective redefines the infrastructure of the cosmos. We are not byproducts of a random explosion, but the processed content of a star that collapsed in another dimensional plane. The critical density required to rupture the fabric of spacetime creates a new bubble of reality. What we call the expansion of the universe is, in truth, the outflow from a massive white hole. Theoretical physics now suggests that every abyss in the sky is a portal of creation.
In 1916, as the world tore itself apart in conflict, Carl Schwarzschild found the first exact solution to Einstein's equations. He described a geometry where gravity is so intense that space-time curves back upon itself. This point of no return, the Schwarzschild radius, defines the boundary of a black hole. But the mathematics is symmetrical. For every solution describing the inward flow of matter, there exists a mirrored solution describing its exit. The metric does not distinguish the direction of time. If matter can be compressed to a single point, physical logic demands a mechanism for decompression. Schwarzschild's mathematical framework predicted the abyss long before we had telescopes to observe it. What he did not know was that his discovery would pave the way for the idea that the universe possesses escape valves. The rigidity of the numbers points toward a reality where collapse is merely the prelude to expansion. The information paradox represents the most significant crisis in modern physics. If an object, such as a book, is dropped into a black hole, does the data it contains vanish forever? In 1974, Stephen Hawking proposed that black holes evaporate, yet this would create a data vacuum that violates the fundamental laws of quantum mechanics. The theory of reverse singularity provides an elegant resolution. Information is not destroyed. Instead, it is processed and expelled through a white hole at a different coordinate in spacetime. Consider the black hole as a file shredder and the white hole as the printer that reconstructs this data into a new configuration. This state transfer ensures that the conservation of information is upheld. The infrastructure of the universe functions as an indestructible backup system. What enters as stellar dust on one side emerges as primordial hydrogen on the other. Entropy is not the conclusion, but a necessary phase shift for cosmic rebirth. White holes are the mathematical mirror of black holes. While a black hole possesses an event horizon from which nothing can escape, a white hole possesses a horizon that nothing can enter. They are regions of pure ejection. In general relativity, the existence of one implies the possibility of the other. The Kruskal-Sakaris solution connects these two regions through a tunnel. Imagine an hourglass where sand falls from one reservoir to another. The bottleneck is the singularity. However, we have never observed a white hole in deep space. Why? The answer may be that we are looking in the wrong direction. If the Big Bang was a massive ejection of matter and energy, it possesses all the characteristics of a white hole. Our universe does not contain white holes, it is the result of one. This perfect symmetry suggests that the cosmic infrastructure is composed of input and output pairs, operating on timescales that defy human perception.
The reverse singularity is the concept that the point of infinite density at the center of a black hole undergoes a rebound. Instead of crushing matter into nothingness, quantum pressure reaches a critical limit and inverts the process. This phenomenon is known as the Big Bounce. When a massive star collapses, it reaches a state of compression so extreme that the laws of classical physics fail. At this moment, gravity becomes repulsive. Matter is expelled outward into a new dimension, creating a new spacetime. The Big Bang that gave rise to our world would therefore be the other side of a black hole formed in an ancestral universe. This theory eliminates the need for a beginning of time from absolute nothingness. The infrastructure of reality is cyclical and self-sustaining. Each stellar collapse is a seed for a new explosion of life and galaxies, maintaining the eternal flow of matter.
Loop quantum gravity proposes that space-time is not continuous, but composed of small, discrete loops. This granularity prevents matter from reaching infinite density. When a black hole attempts to compress matter beyond the Planck length, space reacts like a spring compressed to its limit. It rebounds. This quantum bounce transforms the black hole into a white hole in a fraction of a second, although for us, external observers, time appears frozen due to time dilation. This granular infrastructure of the cosmos resolves the problem of singularities that plagued Einstein. There are no bottomless pits, only extremely rapid phase transitions. Matter falling into the event horizon is processed by this quantum network and redistributed. The universe operates like an internal combustion engine, where collapse is the compression and the Big Bang is the ignition. The microscale defines the macro expansion observed through our telescopes. Physicists detest infinity. When a theory predicts infinite density, it is a sign that the theory is incomplete. The singularity at the heart of a black hole is a miscalculation of general relativity. In physical reality, there must be a limit. The theory of reverse singularity replaces the endpoint with a transition. Upon reaching Planck density, matter reaches a state of saturation. The infrastructure of space-time can no longer support the load, and energy is forced to expand. This rejection of infinite density is what allows for the existence of multiple universes. If matter were simply destroyed, the cosmos would be a system of total loss. Instead, it is a recycling system. What we perceive as a devouring abyss is in fact a high-pressure filter. The physics of the impossible becomes the engineering of cosmic birth. Infinity is merely the name we give to what we cannot yet measure.
Einstein-Rosen bridges, commonly known as wormholes, serve as the connecting infrastructure between black and white holes. In 1935, Einstein and Nathan Rosen demonstrated that the geometry of a black hole could be extended to link with another region of space. This bridge is not merely a spatial shortcut, but a birth canal. If our universe emerged from a white hole, the Einstein-Rosen bridge is the umbilical cord linking us to the parent universe. This connection would explain why the universe appears so uniform in every direction. Information was equalized through the tunnel prior to expansion. Although traversing these tunnels is considered impossible for biological beings due to tidal forces, primordial matter flows through them like water in a cosmic pipeline. The abyss is not a dead end, but a corridor to a new room in the vast mansion of the multiverse.
Lee Smolin proposed a revolutionary idea in 1992: cosmological natural selection. He suggested that universes producing more black holes have more descendants. If every black hole generates a new universe via a white hole, then the laws of physics favoring the formation of stars and black holes would be the most common. This would explain why the constants of nature appear so finely tuned for life. It is not an accident, it is evolution. The infrastructure of the cosmos is designed for replication. Universes that fail to collapse stars die without leaving heirs. We live in a universe that is extremely efficient at creating black holes, suggesting we are part of a successful lineage. The reverse singularity is the reproductive mechanism of the multiverse. Every abyss in the night sky is a promise of continuity. Biology and astrophysics merge into a narrative of survival on a galactic scale, where collapse is the key to immortality.
Black hole thermodynamics reveals that these objects possess temperature and entropy. Jacob Bekenstein and Stephen Hawking demonstrated that entropy is proportional to the area of the event horizon, not the volume. This implies that all information from an object falling into a black hole is encoded on its surface. This holographic infrastructure is fundamental to the theory of the reverse singularity. If the information resides on the surface, it can be transferred to the white hole without being lost in the central singularity. The emitted heat, Hawking radiation, is the signal that the black hole is processing energy. The void is neither cold nor silent. It pulses with the activity of matter conversion. Entropy dictates the arrow of time, but in a black-white hole system, this arrow can be reset. The chaos of a dying universe becomes the order of a new Big Bang, maintaining the thermal equilibrium of the multiverse.
The Big Bounce concept suggests that the Big Bang was not the beginning of everything, but a rebound from a prior collapse. Rather than an explosion from a singularity, imagine a balloon compressed to its absolute limit and then violently released. The infrastructure of space-time possesses an intrinsic elasticity. When density reaches the critical threshold of 10 to the 93rd power grams per cubic centimeter, gravity reverses its sign. What was once attraction becomes repulsion. This quantum leap expels the accumulated matter, initiating the expansion phase observed today. Evidence of this rebound may be embedded within the fluctuations of the cosmic microwave background radiation. If the universe transitioned from a black hole to a white hole, it would carry the signatures of the preceding collapse. Time would not be a linear progression, but a succession of cosmic cycles. The Big Bang is simply the moment the universe begins its expansion anew.
The matryoshka structure is the logical conclusion of black hole cosmology. If our universe exists inside a black hole, and our universe itself contains millions of black holes, then each of those abysses contains new universes. It becomes an infinite hierarchy of nested realities. This fractal infrastructure implies that the cosmos is far larger than the observable horizon suggests. Each level of the matryoshka possesses its own physical laws, slightly altered by the process of collapse and rebound. What we call the universe is merely one layer of an endless cosmic onion. This perspective removes humanity from the center of any importance, yet places us as part of a vast, self-replicating organism. The reverse singularity ensures that life and matter continue to flourish in new bubbles of space-time, regardless of the fate of our own sun. The infrastructure of existence is an infinite ladder where each step is a new Big Bang.
The cosmic microwave background radiation is the residual glow of the Big Bang. But when scientists analyze it with extreme precision, they search for anomalies that should not be there. Concentric circles of uniform temperature could be evidence of collisions between universes or of the rebound process of a black hole. The data infrastructure of the sky is our only record of the beginning. If we emerged from a reverse singularity, the pattern of matter distribution should reflect the rotation and mass of the original black hole. These scars would be definitive proof that we are not an isolated event. The statistical analysis of these fluctuations is the deepest form of archaeology we can perform. We are excavating the debris of a dimensional stellar collapse in order to understand our own origin. The map of primordial heat is the technical diagram of our creation, waiting to be deciphered by minds that do not fear the abyss.
Scientists use laboratory analogs to study event horizons. By using water tanks or cryogenic fluids, they create vortices where waves cannot escape. This fluid mechanical model of spacetime allows researchers to observe black hole-like behavior on a controlled scale. If spacetime behaves like a fluid, then the transition from a black hole to a white hole becomes a change in flow. The experimental infrastructure suggests that event horizons are not solid barriers, but zones of dynamic transition. The study of these analogs reinforces the idea that the reverse singularity could be a natural physical process, not merely a mathematical fantasy. When the flow of a fluid is interrupted, it creates turbulence and redirection. The Big Bang could be interpreted as the maximum turbulence of a cosmic fluid forced through a gravitational bottleneck. The simplicity of a whirlpool in water may contain the key to the complexity of the birth of galaxies and the flow of time. The search for the origin of the universe is not only scientific, it is also a question of prestige and geopolitical power. Nations invest billions in particle accelerators and space telescopes, such as the James Webb Space Telescope, to validate or refute theories like the reverse singularity. The global scientific infrastructure has become a battlefield for intellectual influence. Whoever deciphers the code of the Big Bang will shape humanity's fundamental narrative. In the 20th century, the race was to the moon. In the 21st, it is toward the event horizon. International collaboration at institutions like CERN or through observations by the Event Horizon Telescope collaboration shows that understanding the abyss requires an unprecedented union of resources. Yet the competition for technological patents derived from this fundamental research is fierce. Space science has become a new form of diplomacy. Understanding whether we live inside a black hole could transform our knowledge of energy, propulsion, and even Earth's place on the cosmic chessboard.
The Oppenheimer-Volkoff limit defines the maximum mass a neutron star can have before it inevitably collapses into a black hole. It represents the breaking point of stellar structure. When the degeneracy pressure of neutrons can no longer support the crushing weight of gravity, the collapse becomes catastrophic. Calculated in 1939 by J. Robert Oppenheimer and George Volkoff, this limit marks the boundary between ordinary matter and the abyss. If the theory of the white hole or a reverse singularity is correct, then this threshold could also act as the trigger for the birth of a new universe. Below this mass, a star remains a dense stellar corpse. Above it, it may become a portal. The precision of this calculation is crucial for understanding how many potential seeds of universes might exist within our galaxy. Each time a star crosses this boundary, a new Big Bang could be unfolding in an inaccessible dimension. In this view, collapse is not a structural failure, but the fulfillment of a geometric destiny.
Primordial black holes are thought to have formed shortly after the Big Bang, not from the collapse of stars, but from extreme density fluctuations in the young universe. In some theories, they may represent part of the hidden infrastructure of dark matter.
If our universe emerged from a white hole, then it may have been filled with these tiny gravitational abysses from the very beginning. These objects could act as gravitational seeds, pulling in gas and dust that eventually formed the first galaxies. The reverse singularity hypothesis suggests that primordial black holes might even be residual connections to a parent universe. In that sense, they would be fossils of creation. Detecting them through gravitational lensing would radically change our understanding of cosmic evolution. Rather than being mere cosmic devourers, they may function as the scaffolding on which the structure of the visible universe was built. The abyss was present from the beginning, shaping every star that shines today, an invisible skeleton underlying reality itself.
General relativity shows that time can be distorted dramatically near an event horizon. To an external observer, an object falling into a black hole appears to slow down more and more, almost freezing at the edge forever. However, for the object itself, time passes normally as it continues its descent toward the interior. This difference in perception may hide phenomena we cannot easily observe, such as white holes. If a universe can emerge through a reverse singularity, its birth might take billions of years from our perspective, while occurring almost instantaneously for the collapsing matter involved. The temporal infrastructure of the cosmos is therefore relative and flexible. What we call the past of the Big Bang could, in principle, be unfolding now inside a black hole somewhere in Andromeda. From this viewpoint, the separation between beginning and end becomes a construct of our observational scale. Near the abyss, time bends as profoundly as space itself, merging the moment of destruction with the moment of creation.
If we live in a universe that is itself a black hole, the fate of civilizations may ultimately be determined by the geometry of space-time. Over immense timescales, stars will exhaust their nuclear fuel, and the cosmos will drift toward darkness and cold. This scenario is often associated with the long-term heat death of the universe. Yet the idea of a reverse singularity introduces a more speculative possibility. Matter, including the atoms that make up our bodies and the remnants of our civilizations, may eventually fall into black holes. In some theoretical models, those collapses could trigger new cosmic expansions similar to another Big Bang, but in a separate space-time region. From this perspective, life becomes a temporary phase in the cosmic processing of energy. Highly advanced civilizations might even attempt to manipulate black holes to transmit information, engineered particles, or biological seeds into the next cosmic cycle. In that framework, the abyss stops being merely a tomb and becomes something closer to an arc. Our existence would then not be a random accident, but a byproduct of a system that continually renews itself. The multiverse becomes an ocean of possibilities, where every collapse could be the beginning of another cosmos, ensuring that complexity and structure never disappear completely into the void. The theory of the reverse singularity pushes us to abandon the idea of a single, isolated universe. Instead, we may be part of a continuous flow of matter and energy passing through event horizons. In this view, the infrastructure of the cosmos resembles a network of interconnected abysses, where black holes and white holes act like valves in a vast, pulsating cosmic heart. The mystery of creation would not lie only in a distant and unreachable past, but in every place in space where gravity overcomes matter. When we look at the sky, we are not just seeing stars,
We may be witnessing the engines of future worlds. Science increasingly suggests that an ending can simply be a change in perspective. The abyss may not be the opposite of life, but its deepest womb. Understanding this possibility means accepting our nature as stardust traveling across dimensions. The universe is not merely strange, it could be a machine of perpetual rebirth. And conscious beings like us may be the rare witnesses capable of recognizing that cycle.